Alright, so let us take a look at this simulation on how a stationary wave is formed by two progressive waves. Okay, so first thing first, what is a progressive wave? Progressive wave just means a wave transferring energy from one point to another point. So for example, you look at this blue color wave, it's traveling at 1 meter per second towards the right hand side. So this is a form of progressive wave. Of course, one progressive wave is not enough to form a stationary wave, because stationary wave you need two progressive wave, right, traveling in opposite direction with the same speed, with the same wavelength and same amplitude. Okay, let me put the another progressive wave, right. Okay, you look at this red color wave is traveling towards the left hand side, then this blue color wave, right, is traveling towards the right hand side at the same speed, same wavelength, same amplitude, and of course the same frequency. Okay, so the end result, when they superpose, right, they will form something called a stationary wave. So for this stationary wave, the wave is not progressing. So it's not moving towards the left hand side, it's not moving towards the right hand side. So it's just stationary there. So the energy is not being transferred from one point to another point. It's just being stored in this stationary wave. Okay, and there's no distinctive feature about your stationary wave. So looking at this point, right, this is what I call a node point. A node means displacement node, meaning that there's no oscillation. Means that the particle right here, right, doesn't oscillate at all. This is formed due to your destructive interference. So let me just pause this simulation for a while, and I show the two wave here. Okay, so looking at these two wave, when they superpose, right, so I do a step animation first. Okay, so you look at this blue color wave and the red color wave. So at this particular location, the blue color wave have a positive displacement from the equilibrium. For the red color wave, also have a negative displacement from the equilibrium. So when they add up, right, it will always form a zero displacement. So that's why it's always a node point right here. Okay, what about here? So likewise, right, so the red color wave have a positive displacement. So let's just say it's positive 2 meter, for example. The blue color wave have a negative 2 meter. So when you add up the vector sum, 2 plus negative 2 will always result in a 0 displacement. So that's why all this part, all this point is actually your node point, or what I call destructive interference point. Okay, what about all these anti-node points? So anti-node, so this is your anti-node, this is your anti-node, this is your anti-node, this is your anti-node. These are formed by your constructive interference. Let me just play first. Okay, so I pause. So look at this anti-node point. So it's actually something like a crest, right? So this is actually formed by your crest adding on with a crest, meaning the red color crest, right, add on with a blue color crest, right, to form an even bigger crest. So this is a form of constructive interference. Okay, what about this point? So this is also a constructive interference. This is your anti-node. So this is formed by the blue color trough add on with blue color trough to form an even bigger trough. So that is how a stationary wave is formed. So you just need to know how are the nodes formed and how are the anti-nodes formed. That's it.